Today we're talking about modeling data with quadratic functions. A quadratic function can be written in the form ax squared plus bx plus c, where ax squared is your quadratic term, bx is your linear term, and c is your constant term. So in problem 1, we're going to identify whether the functions given below are linear or quadratic. So for this first one, a here, we are going to FOIL. So we're going to take x times x, which gives me x squared. X times negative 2 gives me negative 2x. Negative 1 times x gives me negative x. And 1 times 2 gives me positive 2. So if I'm combining these like terms, I get x squared minus 3x plus 2. And since I have an x squared term, this is a quadratic. So for b, we're going to take and distribute this x, so I get x times x is x squared, and x times negative 1 is negative x, and then I have minus x squared minus x. So since I have a positive x squared and a negative x squared, they're going to go away, and I'm going to be left with negative 2x. So that means this is linear. So the graph of a quadratic function is a parabola shown like in this graph here. We've talked about parabolas before, but this is just a nice little review. So writing a quadratic function from data. So if I'm given some data and I want to find the quadratic function representing this data set, we are going to find f of 2, helps if I do this correctly, 2 equals 3. So that means I can take, from the table I know f of 2 equals 3, so I can take 4a plus 2b plus c equals 3. And then f of 3 equals 13. So 9a plus 3b plus c equals 13. And then f of 4 equals 29. So then I have 16a plus 4b plus c equals 29. So then for solving these equations for a, b, and c, well, let's solve. So since we have a system, we can do a couple different things. We could use our matrix, or we talked about last time, and do 4, 9, 16, 2, 3, and 4, 1, 1, and 1, 3, 13, and 29. We could use that if we wanted. But when you solve them algebraically, you get a equals 3, b equals negative 5, and c equals 1. So you could also plug this table into Desmos and use this, y1 approximate ax1 plus bx plus c to get a, b, and c is 1. I forgot to write that. So now I have the function y equals 3x squared minus 5x plus 1. So that is my function.